David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic, coordinate geometry review. So we're going to go through this chapter and I'm just going to highlight all the different formulas and techniques that we did along the way. We started with finding the distance between 2 points on the coordinate plane, and that led us to the distance formula. So for any 2 points, x1, y1 and x2, y2, the distance is given by this equation. You take the difference of x2 and x1, square that, add it to the difference of y2 and y1 squared, and then take the square root of the whole thing. So let's do a problem. Let's find the distance between the point 8,5 and 11,9. I always like to do this. That way I don't get confused. So the distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. This is 3, squared is 9. And this is 4, squared is 16. So that distance is 5. Then we also looked at the slope formula. And let's talk a little bit about what slope means. Slope, also gradient. Those two words are used interchangeably. We use the letter m to signify the slope. The slope is just the rise over the run. It's just a fraction. So between 2 points on the coordinate plane, the slope is just how far up do you have to go to get to the other one, divided by how far over do you have to go. Okay, so change in y over change in x, and then our formula is just this. y2 minus y1 over x2 minus x1. And this is just the change in y over the change in x. So let's do a problem. In fact, pause the video right now if you think you can do that one. Find the slope between these 2 points. Okay, let's see how you did. I always like to do this. That way you don't get discombobulated. Slope, which is m, equals y2, 10 minus y1, which is negative 15, over x2, which is 1, minus 6. Now, notice how the negative signs are part of the formula. Okay? So when I did minus negative 15, I had to bring that negative 15 down. If I left it off, I'd get the wrong answer. So let's do this. 10 minus negative 15 is 10 plus 15, which is just 25 on the top. And 1 minus 6 is negative 5. So this is going to reduce down to negative 5. Because 25 over negative 5 is just negative 5. Okay, so those are the first 3 formulas. I did some basic problems as examples. Just know that there are more complicated problems, and you've seen those in the homework and stuff like that, so you want to make sure you practice some of those too. Okay, before we moved on into line equations, we looked at parallel and perpendicular lines, and we looked at their slopes. So here's some definitions for you. If line A is parallel, this is the symbol for is parallel, to line B, then A and B have the same slope. Just pretty straightforward. Parallel lines never meet, so it makes sense that they have the same slope, because if this one has a little different slope, somewhere they're going to meet. And so we use this information to set up a number of things, but basically you might be told somewhere along the way that line A has a slope of such and such, line B, which is parallel to A, and then they'll tell you some other stuff about B. You might have to find its equation. So you use the slope from A, because you know A is parallel to B, has the same slope. So that's how they might use that idea. Now, perpendicular is a little bit more complicated. Line D is perpendicular to line E. That's a symbol for perpendicular. If that's the case, then D and E have slopes that are the negative reciprocals of each other. So what that means, the negative reciprocal, is whatever the slope of 1 is, it can be expressed as a fraction. You flip it, you turn the fraction over, and you change the sign. So a reciprocal of a fraction is just turning it over. A negative reciprocal is changing the sign. So check this out. If the slope of D is 3/4, then what is the slope of E? Now pause the video and think about it if you haven't already figured it out. If D is 3/4 and E has the slope that's the negative reciprocal of 3/4, what would that slope be? Okay, if you wrote negative 4 over 3, you were correct. What I see students do a lot is they remember to flip the fraction, but they forget to change its sign. And if you do that, you won't get all the points on the problem. After doing distance, midpoint, and gradient, we moved on to line equations. And we spent about 4 lessons working on line equations. So generally we had 3 different forms. General form looked like this: ax plus, or maybe minus, by equals c. And remember, a, b, and c have to be integers, no fractions, and the a on the x term has to be positive. I wrote plus or minus here because the b term could be negative or positive, as well the c could be negative or positive. Okay, so that's general form. Next we looked at gradient form, and gradient and slope, these 2 words mean the same thing. They can be interchangeable. So gradient intercept form looked like this: y equals mx plus b. M is slope. We've already used that letter for slope. This is the y-intercept, which is in the form of 0, b. So whatever that number is, you know that's the coordinate of the y-intercept, where the line cuts the y-axis on the coordinate plane. Okay, point slope, there were 2 forms for point slope. We had this one. We had y minus b equals m times x minus a, where a and b are some point that's on that line. And then we also rearranged this into perhaps a more useful form, which was m equals y minus b over x minus a. Either one of those forms can work if you have a point and a slope and you're asked to come up with the line equation. What followed was a series of activities that basically had one thing in common. You were given some information, you were given a diagram, and you had to come up with an equation of a line. Okay, so at the basic level, it might have been a problem like this one, where we have a line with a slope of 1/2 and it passes through the point 1, 5. So what we're going to do here is we're going to find the slope-intercept form of that line equation. So here is my equation form. This is the point-slope form. This is all ready to start doing some plugging in. So I'm going to get y minus b, that's my 5, equals m, which is 1/2, times x minus a, which is 1. So that's my plug-in step. Now I just need to rearrange this and get it into slope-intercept form. So the first thing I'm going to do, bring that down, I'm going to distribute my 1/2 here. So that's 1/2 x minus 1/2. And now I'm not quite there. Remember, slope-intercept is the equation solved for y. So I need to add 5 to both sides. So I'm going to get y equals 1/2 x. And when I add 5 to 1/2, I'm adding 10 halves, but I'm subtracting 1/2. So I've got 10 halves there. I added it by 1/2 less. So this is 9/2. There's my equation. That's slope-intercept form. We know our slope, it's sitting right there, and here's our y-intercept. Now, one of the things you might be asked to do is convert a slope-intercept form equation into general form. And you can see here, we're nowhere near general form. I've got some fractions here. I've got to rearrange it. My constant's on the wrong side. My y is on the wrong side. So what I'm going to do is first, what I'm going to do first is deal with the fractions. Notice how these are both over 2. So if I just multiply the whole equation on both sides by 2, I'm going to get 2y equals 2 times 1/2 is just 1x. 2 times 9 halves is 18 halves, which is just 9. Okay, so now I got rid of my fractions. Now I just need to rearrange this. So the 2y has to go to that side, and the plus 9 has to come to this side. So I'm going to subtract 2y from this side, subtract 9 from this side, and I'm going to wind up with x minus 2y equals negative 9. And that's my general form. So this is slope-intercept form right there. And this is general form. Okay, so that's one example of finding a line equation. We did a lot of different ones and we did more complicated ones. So when you review, you're going to need to dig into some of those other types of problems. There'll be a review assignment, do that, and then you can also drill back into past activities and you'll see there's problems that I didn't assign that you could tackle. And of course, if you want more practice, you can't find it in the book, just talk to me, I'll give you more practice. What? Did I forget something?
The midpoint formula!
Oh no! Okay, so let's go over the midpoint formula. It's basically just m for midpoint in this. And what we do is we take our two x coordinates, add them up, divide by 2. Take our two y coordinates, add them up, divide by 2. And remember, this is a coordinate point, so it's separated by a comma. This is not an equation that way. Okay? So let's do an example. I have 2 points, A, 2, -7, and B, -4, 9. And let's find out what the midpoint of the segment connecting these 2 points is. So you want to pay attention to your plug-in step. The midpoint is going to be the two x coordinates added up. So that's going to be 2 plus -4 over 2, comma, and then the y coordinates, -7 plus 9 over... Okay, so now we just have to crunch these numbers, and it's pretty straightforward. 2 plus -4 is just 2 minus 4, so that's going to be -2 over 2. And -7 plus 9 is +2 over 2. This one's going to come out nicely. -2 over 2 is -1, and 2 over 2 is 1. So our midpoint for the segment connecting these 2 points is -1, 1. So I fixed that. Are you guys happy? Awesome. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.